Electric circuits. This presentation will discuss the basic laws in electrical circuits. Topics discussed are Ohm's law, circuit configuration, series and parallel circuits, definitions of nodes and branches, Kirchhoff's law statements, procedure to solve series circuits for resistance, current and voltage, procedure to solve parallel circuits for resistance, current and voltage. Ohm's law defines the relationship between voltage, current and resistance in an electrical circuit. Current in a resistor varies in direction proportional to the voltage applied to it and is inversely proportional to the resistor value. This statement is stated mathematically as I is equal to V by R, where I is current through the resistor in amperes, V is potential difference across the resistor in volts, and R is the value of resistor in ohms. We can form a Ohm's law triangle which describes the mathematical relationship of Ohm's law as V, I, R. When you want to find I, we can write V by R. When you want to find I, we can write V by R. When you want to write V, we can write IR. And when you want to write R, we can write V by I. A simple example that explains the Ohm's law can be written as follows. A flashlight shown uses a 6 volts battery and has a bulb with resistance of 150 ohms. When the flashlight is on, how much current will it be drawn from the battery? So a simple circuit that can be written is a resistance of the flashlight and the battery is 6 volts. So the current through this is 6 volts by 150 ohms, which is 0.04 amperes. I is voltage of the battery and R is resistance of the flashlight. In the practical networks, many resistances or elements are connected in combinations. These combinations, we term them as the circuit's configuration. So normally the circuits are connected in series and in parallel. Series circuits. Components are connected from end to end. There is only a single path for the current to flow. In parallel circuits, both ends of the components are connected together. There are multiple paths for current to flow. In series circuits, the total resistance is returned by sum of the resistances of the elements, and voltage across the voltage here is equal to the source voltage, or the terminal voltage is equal to voltage drops across all the elements that are connected in series. Here resistance of these elements are R1, R2, R3. Voltage across R1 is VR1, voltage across R2 is VR2, voltage across R3 is VR3. Sum of these three is equal to 12 volts. In parallel circuits, characteristics of parallel circuits are stated as follows. Voltage across every parallel component is equal. Total resistance is equal to the reciprocal of the sum of some of the elements. Reciprocal is, that is, 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. And the total current is IR1 plus IR2 plus IR3 is the total current in the parallel branch. Common circuit elements and their symbols that are used in electrical networks are for battery, resistor, switch, capacitor, inductor and lamp are as follows. Node is a point where two or three elements or more than two elements meet. So here it is a voltage source and resistor meet at this point, it is node, and here these three resistors meet, it is also termed as a node. And in and branch, each element of electrical network we term it as a branch. Here it is a voltage branch voltage, branch current are written as voltage across the branch is written as V and branch current is written as I. Kirchhoff's voltage law. The sum of all the voltage drops in a series circuit equals to the total applied voltage. Kirchhoff's current law. The total current in parallel circuit is equals to the sum of the individual branch currents. Characteristics of series circuits. The total current flowing in every series component is equal. So when all the resistors are connected in series, we call it as a series circuit, and when all the we call it as a series circuit. And while analyzing the series circuit, the sum of resistances are to be considered and total current through the network is to be analyzed, and from that voltage across each and every element is to be obtained. This is the common procedure that we follow in analyzing any electrical network. So this particular circuit, with this particular when we wanted to verify Kirchhoff's voltage law, sum of all voltage drops in a series circuit is equal to the total applied voltage. So sum of voltage drops across all the series elements is equal to the total applied voltage. To find here a simple example is discussed to find the total current in the circuit, total resistance in the circuit, current flowing through each component, and voltage across each and every element of the network. And finally, it is asked to verify Kirchhoff's voltage law. Total resistance of the network is, because these three are connected in series, it is R1 plus R2 plus R3. And voltage across each component is obtained first by obtaining the current through each element. So total resistance across this is equal to R1 plus R2 plus R3, and total current is V by R. V is 12 here and R is 1.89 kilo ohms. It gives the total current through the network, and the same is passed through all the elements. So IR1, IR2 and IR3 is same. Now to find voltage across this, I into R, voltage across this is I into R, and voltage across this is this I into R. This gives voltage across each and every component. To verify Kirchhoff's law, total voltage is VR1 plus VR2 plus VR3. So Kirchhoff's voltage law is verified in the simple series circuit. And this is how we solve the problem of parallel circuit, basically by verifying the Kirchhoff's current law, by applying Kirchhoff's current law. So a parallel circuit is given with R1, R2, R3 as resistors, and the voltage applied here is Vt. To verify Kirchhoff's current law, algebraic sum of the currents at a node is equal to 0. That is, sum of the currents entering at the node is equal to sum of the currents leaving at this particular node. Here also it is asked to find the total resistance of the circuit, current through the branches, and and it is also asked to verify the Kirchhoff's current law. This is how we proceed. So IR1, IR2, IR3 are obtained first by obtaining the value of IT first, and then VR1, VR2, VR3 is obtained. From that, IR1, IR2 and IR3 can be written. When you observe here, VR1, VR2, VR3 are same as VT because the starting node and terminal node of each and every element are same as starting node and terminal node of this VT. So RT is 1 by R1 plus 1 by R2 plus 1 by R3, and IT is equal to sum of these three. And Kirchhoff's current law is verified by IT is IR1 plus IR2 plus IR3. And summary of this presentation is we have seen the statements of Ohm's law, concepts of nodes, branches, series and parallel circuits, Kirchhoff's current law and voltage law, and we have seen the procedure to solve series circuits and parallel circuits. You will be in a position to solve these circuits. Just to give the hint, to find the resistance across these two are in series, parallel with this, these two are in series, and then parallel combinations. This parallel combination would become series with this, and the net one is parallel to this. And here also, to find the DC current shown in the to find the DC current of the circuit shown in figure, we find these three are in parallel and a combination is in series with this. Apply V by R so that you get the current, and from that you can find the voltages. In the similar procedure, you can solve, or you will be in a position to attempt these problems now. Thank you.